Hello class, we are going to continue our episode on 30 questions per day analysis so that we can master our applied electricity very well so that whatever questions that comes we can face it strongly. Okay, so if you are really enjoying the episode, just put in the comment section yeah, okay, so that we can all proceed and then do more help each other. Okay, so the question states that what? Find the Thevenin's resistance to the left of the terminals in the circuit as shown in figure 4, right? So this is a Thevenin's question, and then we need to know the rules for Thevenin, right? And we are saying that the Thevenin's equivalent circuit this is mostly one of the objective questions. The Thevenin's equivalent circuit VTH, right, should be represented in this form. The VTH with what? RTH, and then in series with what? The load resistance. The resistances we are finding components across. In this case, we have terminal AB at this point, right? Since we have terminal AB at this point, that means that the load resistance is what? 1 ohms, right? 1 ohms, okay. So anytime we are solving a question like this, all what we need to do is just take the load resistance out, just like we have done here. And then the next one is to find the VTH and the RTH. But here the question is what? Restricting us to certain things we need to do. Okay. And the question states clearly that we should find the Thevenin's resistance to the left of the circuit. You get it? So let's look at it. How do we find the Thevenin's resistance? All what we need is that anytime we are finding the Thevenin's equivalent circuit or the Thevenin's resistance, we remove all passive active components, the voltage source and that of the current source. So our systems now tends to be what? Our system will now tends to be what? A resistance. So the 6 ohm resistance, right? And then we have another resistance which is what? 6 ohms again. Okay. We have another resistance here which is what? 4 ohms. And then finally where we are finding the what? The RTH across. Okay. So RTH. Now anytime you are finding the RTH, this is a very nice secret we need to know. You assume that there's a current moving from that end. Else, because this one is open circuit, you are going to add this together as what? A series circuit. Okay. So you assume there's a current moving from where you have inserted your RTH. If that's the case, then you can add this and this becomes what? Power. So we realize that this particular side is what? A series circuit because only one current that will flow through that end. So the resulting circuit will now tends to be 12 ohms, right? And then we have what? 4 ohms, right? And then finally we have what? The RTH at this point. So this and this becomes what? Power, right? So we can see our RTH, right, is equal to 12 power 4, which is equal to 12 times 4, all on what? 12 plus 4, which will give us a resulting value of what? 3 ohms, right? So realize that in the question we don't have the answer in it. So if you are bold enough and you understand your analysis, you just write your 3 ohms in the question and you move. Let's move on to question number 90, right? The question states clearly that we should determine the Thevenin's voltage to the left of the terminals in the circuit, right? And anytime you are finding the Thevenin's equivalent circuit, what you need to do is that what? If you are finding the Thevenin's voltage, all components will remain the same. So we have what? A voltage source here, which is what? The 12 volts. And then we have the resistance remain the same, which is what? 6 ohms. The current in the circuit also remain the same, which is what? 2 amps. And then we have our resistance, which is what? 6 ohms here. Now we also have another resistance, which is what? 4 ohms. And then finally our terminal where we can what? We can insert what? Our component. Here, what are we looking for? We're looking for the Thevenin's voltage. So we put the VTH here, and then we are saying that the Thevenin voltage is the same as what? Open circuit what? Voltage, right? And anytime we are open circuit, means that there will not be any current flowing through that particular side, right? So zero current, so we'll get a total voltage. Right, so since this side and the other side is parallel, we are saying that the voltage here is the same as the voltage here. So therefore, we can see that what we are going to look for the voltage that is coming to the 4 ohms, and that will be the same voltage here. So we draw the circuit, okay, where we have only that resistance, right? So we have 6 ohms here. This is our 12 volts, and then don't forget this is our current 2 amps, okay. And then finally we have resistance what? 6 ohms and then 4 ohms. So 4 ohms and then 6 ohms. This and this is in series, don't forget. So we can add this and this together. Okay, so let me just do that straightforward and then we go. Okay, so I can see this, and this will give me what? 10 what? Ohms. Okay. Okay. Now what are we looking for? We're looking for the what? The current here. After that we multiply by the 4 ohms to get what? The voltage across that end, and that will be the voltage here. Okay. So how do we do it? We know that the current here is the same as the current across the 4 ohms and the same as the current in the 6 ohms. So here we can use any of the methods to do it. Okay. So I see superposition to be very simple here, where first of all I will first let the voltage act alone, and the current source will be taken out from the circuit. And we know the rules that if a current source is taken out, this one becomes what? Open circuited. So our resulting circuit will be what? A voltage source, right? The 12 ohm voltage with the resistance in series, which is what? The 6 ohms, and another resistance in what? In series, which is what? 10 ohms, because the other one has been open circuited, right? So here, if you are looking for the current is the one current passing through. So we can see our current source, right, is equal to, if when the 12 ohm was acting, the current source was equal to the 12 volt, current is equal to voltage over resistor divided by 16, which will give us what? A resulting value of what? 3 ohm 4 watt amps. Okay. If you want the voltage across that end, because it's the same current, you can see what? If you multiply the what? The current by this particular resistance, you get the what? The voltage there, right? So that will give us 3 ohm 4 times what? The 4 ohms, right? And that will give us 3 volts. So this is the result the 12 ohm has given to us. We are going to look for the result that if these 2 arms is acting alone is going to give us. So letting what? Letting the 2 arms act alone, right? So this is what we'll get. 2 arms is acting alone. Don't forget at that point what? The voltage source will be short circuited. So we have our 6 ohms here, and then finally we have our 10 ohms here, right? So here this current will get here. When the current gets into the junction, it will share between this and what? This. That's current division, right? So we want to look for the current passing through the 10 ohm, and that will be the same as the current passing through the 4 ohms. After that, we just multiply by 4 to get the voltage there, right? The same thing as the one we did. So the current divider in the 4 ohms, right, or in the 10 ohm, is equal to the opposite resistance, right, which is 6, divided by the summation of the 2, which is 16, times the total current, which is 2. This will also give us a resulting value of what? 3 on what? 4, right? So if you want the what? The voltage, you just multiply by 4. Voltage is equal to IR, which is equal to 3 on 4 times what? The 4 ohms, right? Which will also give us 3. So if you want the what? The total voltage there, that will be the summation of these 2 voltages when both of them was acting alone. So the total voltage, which is the Thevenin's voltage, is equal to what? 3 plus 3, and that will give us 6 volts. Okay, so we had 6 volts. That's exactly C. So thank you, and that is all for the Thevenin's analysis. Why are we saying the same as the 6 volt? Is because this side is parallel to this. So the voltage in this 4 ohm is the same as the voltage here, and that will be the end for the class. We are going to solve more questions like this, and by the time you finish solving with me, you'll be confident enough to write any applied electricity questions, knowing clearly that you are going to get your A plus. Bye.